believe it has started. All right, we're going.
Hey everyone, this is Betty Janot from Solo.io, and so Jace Singer-Dumars and I are very excited to be kicking off our first series in service mesh in the real world, and digging into that specifically using Istio. So at this time, I'd like to introduce Christian Posta of Solo.io and Sandeep Parikh of Google to kind of take it away with our first topic, managing egress using Istio. Take it away, guys.
Awesome, thank you. Betty and Jace, and we're going to talk about Istio. We're going to talk about traffic management, and specifically some of the challenges around getting traffic out of your cluster and out of your service mesh to services that live outside of those boundaries. So, like Betty said, my name is Christian. I'm a field CTO at Solo. At Solo, we build tooling to help folks adopt service mesh and make it easier to build on top of it. Oh, yeah. All right. And then my co-presenter here.
Oh, thanks, Christian, and thanks, Betty and Jace, for setting this up. My name is Sandeep Parikh. I'm a cloud native advocate at Google Cloud, and we focus on helping developers, operators, SRE, learn how to use Istio and how to scale their deployments with Istio. So why don't we step into this? So what we're going to cover today is, first we want to lay out a little bit of a challenge around managing egress traffic, and then we want to walk through some example deployments about why that could be something of a challenge and what the need is there. And then we'll go through a handful of solutions that are available today, as well as a solution that uses Istio as well. And then Christian's going to do a demo for us. And then we're going to close up with what's new in Istio 1.2 and open the floor up for any questions. And we'll try to check the chat as well. So feel free to use that for questions or I think that might be the best way to try it out. So our challenge for today is, how do we get a stable outbound origin for egress traffic, right? So what we're trying to do here is make sure that any traffic that's leaving our cluster, in this case, let's say for a Kubernetes cluster, that we've got a stable outbound origin IP or host name, to control for downstream usage. And so if we get into a little bit more detail there, why do we have to worry about things like this? Well, for many deployments that need to communicate with external applications or external systems, those downstream systems need to know where the traffic is coming from. Right? In this kind of basic example here, we've got a pod that's communicating with an external application. That traffic is going straight through it right now, but for more sort of security-minded use cases or solutions, we may need to know where that pod's traffic is originating from, and we want that to be a stable origin point. And the reasons, there are many reasons why folks might want to do this for their deployments. Obviously, chief among them is kind of a secure approach, but specifically, it could be for things like monitoring data exfiltration, monitoring for infiltration of your systems, or just generally for compliance. And most often what we'll see is a firewall sitting in front of an external application or an external system, and the origin needs to be whitelisted in that firewall for traffic to get through. So a couple of specific examples, as we mentioned, so particularly around compliance, right? Things like PCI compliant deployments may require this type of whitelisting approach, or just additional systems that may live outside of your Kubernetes cluster. So things like, legacy applications or database infrastructure, especially in hybrid deployments, this comes up quite often. So you may have pods and services running in a cloud environment, but they've got to reach back to on-premise infrastructure that's, again, protected by a firewall. And again, the need there is for us to know where the traffic is originating from so that we can allow it through the system, and not just where it's originating from today, but where it could come from. And that's where having a managed egress approach makes sense. So for our example deployment that we're going to work off of today, it looks very similar to the diagrams we showed, right? We are going to take a pod running inside of Kubernetes engine, and we're going to try to talk to this external application and go through a firewall. So this is the basics of our deployment today. And as I mentioned, the requirements that we have to achieve here or satisfy is that all outbound traffic must originate from a stable source. Our secure application sits behind a firewall, and we must be able to whitelist that origin or that source in the firewall configuration. Right, so that solves kind of our challenge here of how do we get traffic from that pod through a firewall to the external application, keeping in mind we want to keep that source from a stable perspective. So a couple of the approaches that exist for things like this, right? Often folks will try to use things like NAT or network address translation. In this case, one of the approaches would be to maybe run a set of NAT gateway instances as, on a VM, in this case, compute engine. The benefits here, right, is that we do solve for the stable outbound IP problem or the stable outbound origin part where only the NAT instances or the NAT gateways need to be whitelisted by the firewall, and all pods just send their traffic through the NAT gateway. That solves that sort of requirement, but it does introduce some other challenges. Now we've got to worry about kind of VM lifecycle and the NAT gateway management aspect, and we're getting very coarse-grained traffic controls. That means all traffic has to go through the NAT gateway, not just some of it, not just depending on certain applications or certain needs. Everything needs to travel through that NAT gateway. And so that could be a potential challenge. Another approach would be to use something like a managed NAT infrastructure. This has some of the same problems, but it does offer us the stable outbound IP approach, but it does still bring with it coarse-grained traffic control. Again, every bit of traffic leaving those pods, and imagine, right, this is not just a single pod, but a deployment with, could be hundreds or thousands of pods. All that traffic has to go through the gateway, meaning we don't get a lot of flexibility and control over that, and even though we still get the managed aspect of that service. There's also the approach of setting up a proxy infrastructure. Proxies do give us, again, that stable outbound origin or that source, and they do give us some level of protocol control, so a little bit more fine-grained than kind of a blanket NAT approach. But again, you're introducing other challenges. We've still got the VM and proxy lifecycle management, which is separate from your cluster infrastructure, so another thing to manage. And it's not very particular. Once we're in a protocol approach, we still have kind of a coarse-grained component there. And then the last alternative would be an internal proxy. And this is starting to get closer to what service mesh deployments look like. But with just a blanket proxy by itself, we could solve for the stable outbound problem or the stable origin problem, and we do get the good level of protocol control. But now we've got to worry about managing the deployment and the configuration of this proxy. And in this example scenario here, we've got no control plane, right? There is no central management system for that proxy. So if you have hundreds or thousands of pods or services, controlling and configuring each one of these individual proxies introduces, more of a management challenge than it solves for it. So that brings us to, so let's take a look at building on what Sandip mentioned in the last slide and build up to through a series of different solutions with their various drawbacks. We'll look at a cluster native or a container native solution for, in this case, Kubernetes. We start by looking at an open source project called Kube Static Egress IP. And what this does is it places daemons or runs as a daemon set with a container running on each node that acts as a way to force traffic through a particular gateway that is pinned on a particular node, and you can configure that to have an explicit static egress IP. So as traffic in the Kubernetes cluster is trying to communicate with external systems like databases, message queues, and so on, the traffic will be routed through the particular gateway that you specify using static egress IP, and then we'll take on that static IP that you configured. Now, this is a project, it's an interesting project. It's in alpha quality or alpha state. It requires some manual manipulation to figure out exactly which nodes will be the director and which one
will be the gateway. It doesn't have an automatic, let's say, multi-gateway and leader election algorithm built into it yet, but they are starting to go toward that path. But so take a look at it. It is an interesting solution. So the one that we'll talk about today is built on Istio. So if you have a service mesh like Istio in place, Istio has a construct called a gateway that can be used for allowing traffic into a cluster, as well as managing the traffic going out of the cluster, which we'll talk about in a little bit more detail. At Solo, we've also built a complementary API gateway that allows traffic into your cluster that takes an API-centric approach, built very similarly to the out-of-the-box Istio gateway. But for traffic flowing, once it gets into the cluster, talking amongst its other services, but then may need to make a call out to an external database or external cloud service, we want to have a stable egress IP, and using the Istio egress gateway is one way to solve that. So with Istio, what we need to do first is tell Istio's registry what that external service is and and how to reach it, whether that's a IP address or a DNS entry or host name. We do that in Istio using the service entry resource. And you can see here on the right-hand side, we have an external service that runs at a particular IP, and we configure the service with a host name, in this case http://bin.gcp.external, that will, if we use that host name inside the cluster, then it will, Istio will understand what that is and figure out how to route the traffic to that service. We can also take a look. We specifically said that the location of the service is external to the mesh, and that the addresses and resolution of the endpoints is specified static in this case. Next, what we got to do is configure the egress gateway itself. We need to tell it what protocols, what ports to listen on, and what hosts should be managed by this gateway. And we also set up a destination rule in Istio, kind of to split or give Istio a hint of what traffic is going toward the gateway, and we'll see that in the next config with the virtual service. But specifying the protocol and the hosts for the egress gateway is the first step to setting it up. Okay, the last bit of config we need in Istio, so we have the service entry, which specifies what the service is, where it lives externally, just gives Istio a heads up about it. We looked at configuring the egress gateway, so we specify the protocol and the ports and the hosts to watch out for. And then now with the virtual service in Istio, what we're doing is we're in the first part of this, where we have the HTTP matching rules. We say that for traffic originating inside the mesh that is destined for a particular external host, route that to the egress gateway. That's the first thing we're doing here with this virtual service. Any traffic destined for the external service, route that to the egress gateway, because that's where we want to manage that IP and that well-known egress point. The second match clause here in the virtual service says that if you're trying to route to that particular external service and you are the egress gateway, then route normally to the external service, knowing that the service entry was created there. So that's what helps it find the actual IP address and know that it's external to the mesh. So we have two different clauses here, one for routing from inside the mesh to get to egress gateway, and then one once you're at the egress gateway, routing properly outside of the mesh. So the demo that we're going to look at looks similar to this architecture here, where we have an application. We have a very simple application in a demo. It's going to be the sleep pod from the Istio samples repo. Basically, it just loads up and it just sits there and waits. And you can go in there and run commands and so forth. But then we're going to set it up so that the traffic is going through the egress gateway, through Istio's egress gateway, and then to our external application. And moreover, what we're going to do is we're going to set up a firewall rule that says we cannot allow any traffic into this external application unless it's coming from a known IP. In this case, it'll be the external IP of the egress gateway. So we'll try to set all this up and run it and demo it here now. Okay. So the first thing that I want to point out is if you're getting started with a service mesh, such as Istio, then at Solo we're building a tool called the Service Mesh Hub, which is a management plane for your Istio installations and potentially multiple clusters of Istio. And it gives you the ability to quickly add extensions. So here we can see we have a Istio Service Mesh running. If I click on Install Extensions, we can add additional pieces to our service mesh to increase the value of it. So for example, we can install Flagger, which is a canary analysis project from Weaveworks. We can install Glue, which is an Envoy-based API gateway, which, as I mentioned earlier, complements and extends Istio's capability to API-centric type policies. And we can add additional things, including your own extensions you might build for the mesh or demos that you want to use to showcase the capabilities of the mesh. But once you have one installed, like we do here, then we can go to taking a look at some of its capabilities. And the architecture that I set up, we'll walk through right now. So this is a live demo. I have a script typing it out for me. We'll leave the link at the end of the presentation showing you how this is all done. But I'm not very good at typing in live demos. So let's cross our fingers that everything works out all right. So we see we have our sleep pod running in our Kubernetes cluster. We have Istio running, and specifically we have enabled the egress gateway. Now again, in the sample code, we'll leave you with instructions for how to do all this stuff and set it up. Now, the first thing we have is on the bottom, we have a instance, a GCP instance running with HTTP bin on it. So if we take a look at it and try to call it locally, we can see that we get the correct response. We're calling it /headers, we get the response that we expect. If we try to call this within our sleep pod, then we'll notice that the traffic won't get through and cannot get through because we set up firewall rules that block any traffic that's coming unless it's known traffic. So we get this error here. So what we want to do now is we want to set up a firewall rule, in this case, that allows traffic coming from our egress proxy and allows it to the HTTP bin service. So traffic cannot go directly from our sleep pod and needs to go to the egress gateway first. So we'll create that firewall here using GCP. And once we have that firewall created, we can now set up the routing config in Istio, which I showed earlier. That includes the service entry, the destination rules, the virtual service, and the gateway. So we'll set up those 4 things now. You'll notice that we're setting up the service entry in this first step in the Istio system. This is to let the Istio control plane know about our external service and what IPs and all that stuff that it listens or that it's served on. But we're going to use, and I'll show you the service entry super right here. We're going to use throughout the rest of our routing the host name that we are virtualizing for this inside the cluster. So it listens on a particular external address, but within the cluster, the rest of the routing rules are going to be using this host name. So next, let's create our destination rule, our gateway, and lastly, the rules in our virtual service, which direct the traffic from our sleep pod to the egress and then from egress to the external service. So now that's all set up. On the bottom pane, bottom left-hand pane, we see a log for the sleep pod. On the right-hand pane, we see a log for the egress gateway. Now, when we make our call to our external service, we should see the traffic. We'll see access logs here. We should see the traffic go to our sleep pod proxy, and then to the egress gateway proxy, and then ultimately we should see a successful return. So let's execute that command now. We'll pass in the host name that we use throughout our Istio configs. We see the correct response. On the bottom left-hand pane, we should see an access log okay, we see it. And on the right-hand side, we should see an access log saying that it went through the egress gateway. So we see that from sleep, the traffic was directed to the egress gateway. As you can see here in this access log, from the egress gateway, we can see that it went outbound directly to the HTTP bin service entry that we set up. Okay, so to get even tighter control over this mechanism, because what we did was we rely on Istio's default rules and IP tables manipulation to force traffic through the gateways. We can get even tighter rules and egress policy around what traffic is allowed to leave the pod by using network policy and forcing the traffic either directly through Istio's egress gateway, and in this case, in the example we're looking at, we're allowing the pod to talk with DNS as well as any of the components in the Istio control plane. So you can't go around the Istio proxy, and you can't try to circumvent some of the policies that have been set up to force external traffic through Istio egress gateway. Okay, and now lastly, we'll point out a nice contribution from Tufin, and it specifically is in the Istio ecosystem repository. And what the Tufin folks contributed here is a way of capturing what are the requests inside the proxy, inside the cluster, inside the service mesh, that are trying to leave the service mesh. So we at least get an understanding of what is that external traffic. In previous versions of Istio, that external traffic was automatically blocked from trying to leave the cluster. In more recent versions, that's now opened up. It's allowed, but that creates some interesting security and observability challenges. So with this DNS Discovery plugin, what we can do is we can sit in front of the DNS server and figure out what are the external hosts that we're trying to resolve, and then that can be used to automatically create Istio service entries. So you don't have to manually try to figure out who's using what and when, and manually go create those service entries. So with the DNS Discovery, we can get a traffic analysis almost, and be very explicit about what traffic we're allowing out of the cluster. Back to Sandip for the what's new in Istio.
Cool, thanks, Christian. So we wanted to close out, before we take any questions, we wanted to close out with sort of what's new in Istio. So just a couple of, a few brief stats about Istio 1.2, which was released back on June 18th. So really, kind of 46 major improvements across 300 commits. So that's all well and good. I think the most interesting part of this, and Christian and I were talking about this earlier, was the fact that there were 78 individual different contributors to that release. So there's a pretty solid long tail of community-driven participation from the ecosystem, which we're really excited about seeing. It's not just being driven by a few kind of core contributors like Google, Lyft, IBM, VMware. Right? We were seeing contributions from Pivotal, Red Hat, and a host of other companies, as well as a long tail of individuals. So we're really excited about that, and we're hoping that pace, continues up and to the right as we get towards 1.3 and so on and so forth. I should also mention that Istio is actually at 1.2.2 as of right now, just picking up some minor fixes along the way over the last few weeks. Some of the really critical highlights that I wanted to bring up for Istio 1.2 were the biggest, I think, theme, first and foremost, is release predictability. Right? There was a really solid focus from the team around improving the quality and the timing of releases. And what that means is, one, setting a good quality bar for every release, every major release that comes out, from here on out, but also putting a time box around that and saying, we are going to release major versions every quarter, roughly every 3 months. And so our target for Istio 1.3 is around the September timeframe. And again, we want to set a quality bar that meets that. So that means as we get into August here, if features aren't ready, if they haven't been tested appropriately, they will not make the release cut. And that's important. We want to make sure that we're releasing the software on a predictable basis, but also that there's a predictable quality around each of these releases. And part of what went into that, a big part of it, in fact, was a fair amount of time the team spent on the build, test, and release infrastructure and the kind of underlying machinery there. And so what that means is a handful of new sub-teams were created within the working groups around GitHub workflow, organizing the repositories, a testing methodology, and build and release automation. And what that's giving us, again, is feeding right back into that quality and that timing. So at any given point in any part of the release cycle, we know what their quality is. We know how many tests are passing, how many tests are failing on a much more regular basis. We have a much more predictable release and build pipeline as well. So all of this kind of internal investment is showing up as just a general improvement in quality across the board, which is great. And then there were a lot of new features, but a couple of the ones that I think were really, I think hotly requested by the broader community were things like global log levels for data control planes, right? Instead of having to set individual log levels for the proxies or the control plane components, we have one consistent kind of entry point there. The ability to validate your Kubernetes environment using the istio-ctl command line tool that's included. And then another interesting fix for annotating services and eliminating the need for a container port, which we can talk about a little bit later. Some other big ones were features that went from beta to stable, specifically SNI with ingress, that moved from beta to stable, as well as distributed and service tracing. And then things that moved from alpha to beta were components like certificate management on ingress, started feeding kind of that SNI approach. And then some config-oriented components like resource validation and processing with Galley. So those are some of the really big highlights. Specifically around traffic, I mentioned that original annotation for including including inbound ports. So this makes releasing or deploying the service mesh a little bit easier because we're not forcing them to change some of the YAML they've already deployed. We're just simply adding an optional annotation there, and we'll try to make that a default as we get further out. And then a few other highlights, things like improved locality-based routing and multi-cluster deployments. And some other components like we added the ability to configure the DNS refresh rate for the Istio proxy to reduce the load on the Kubernetes DNS infrastructure as well. And this is just a small sampling. If you go back through and click on the release notes, there is a pretty healthy amount of change that we've done, an improvement we've done in the Istio 1.2 release, and more is coming in 1.3. So with that, Christian, I want to say thank you for joining us. You can always send us questions or comments, etc. on Twitter. Christian is at Christian Posta, and I'm at Circus Monkey on Twitter. For any other additional information, you can always learn more, obviously, by going to istio.io. We've got links in there for Google Cloud, for Solo, for Glue, specifically for the Service Mesh Hub, as well as the link to the demo. That's off my GitHub repo right at the moment. We may move that around, but we'll definitely post an update should we need to relocate that repository where we can both access it. But I think that's everything. And I'm going to quickly take a look at the chat here and go through some questions.
Yeah, we've got one question about the virtual service gateway.
Right. Yeah, so the question is, are the virtual service gateway and destination rules also deployed to the Istio system namespace or to the namespace in which the application is deployed? That's a great question. So it is actually the latter. So the virtual service, the gateway, and the destination rule were deployed in the default namespace along with the sleep pod. The only object that was deployed to the Istio system was the service entry. And so if you think about the way traffic is flowing, the sleep pod doesn't really need to know where the external host is at that point. It just needs to know that traffic for the external host must go through that path. It must follow traffic from itself to the egress gateway, and then the egress gateway sends the traffic to the external host. And now what we've done with the service entry is we're telling the egress gateway what the actual physical IP address, where that external host is located. Right, so depending on the way your network infrastructure is configured, if you're using all DNS resolvable host names, or you're using internal host names, or you're using internal IP addresses, some of that may change. But for the example we chose, where we're using an internal host name but with public IP addresses, that's the configuration we had to go with.
Cool. Any more questions? Going once, going twice. Thanks everyone for joining, and thank you Sandeep and Christian. For folks who, if you enjoyed this, we'll be doing this again, kind of following along onto the Istio release cadence. So look for, go to the Istio YouTube channel. So we'll post probably a few weeks before it's ready, but we're looking to do another one in about October. So we'll see you all online again soon. Thanks.
Thanks everyone.
Thank you all.